All right, should we get started? I'm substituting Bernard today. He has a dentist appointment. Sorry, I'm a bit sick. But today, yeah, for new people joined, we have just updates, Q&A, and yours sharing his work. So it's very unofficial, non-formal call. So yeah, should we start from someone? Maybe Evgeny, do you want to share the latest about the hackathon? We've just done the in-person hackathon in Moscow that last weekend. Do you want to share maybe some insights, or how did it go, or what do you think of the whole thing?
Yeah, sure. It was a lot of fun because it was the first Fluence in-person offline hackathon in maybe 2 years or something. We did only online last year, so brought some additional insights. So which is nice, and it was kind of real quick stress test for the Fluence infrastructure and latest updates to Aqua, because we just really, hackers found a few bugs and we were trying to fix them right away during the weekend. So it was really, really dense and hard. I guess what's most interesting is the projects that people are trying to build. We'll try to have some of them presenting on these calls. But basically, one example is the project that implemented the off-chain governance protocol on Fluence, which was inspired by Snapshot design. But the problem of Snapshot is it's centralized and all the votes and proposals go through a single server. So they created the basically the Fluence service that and the network of Fluence services that had consensus about the voting data and the on-chain verification about the data via Merkle trees and Merkle proofs. And also they had really interesting and well thought mechanism of dispute resolutions with users who can submit on-chain proof if the data was the data submitted by Fluence nodes is not correct. So it's basically the Oracle-based. It's sort of like the distributed Oracle built on Fluence network that provides voting data on chain, and this data can be verified on chain via Merkle trees. So this was pretty cool. The other example, and a few teams actually wanted to do it, was cross-chain NFT transfers, when you basically use Fluence as also the off-chain worker that looks at one chain and sees if the NFT was burned on this chain and then mints this the same NFT on another chain. So it's basically like a transfers. And then so like guys created just one worker. It was kind of centralized in this way, but the idea is also to have the network of such workers that can also have consensus, that can also have some, any on-chain deposits that they can lose if they do not behave properly, if they do not mint the new NFT once something is burned on the original chain. So like we just see really a lot of great, interesting applications of this where fluence is taken as an off-chain complement to some on-chain data, whether it's DAOs or NFTs or something else. So it's pretty cool. And also there was, ideas in order to build integrations, Fluence integration to something else, like to the graph, for example, which sort of would be really cool for the, for the future, where we want to connect many blockchains to Fluence and read data from blockchains easier. We maybe we will maybe publish the bounty specifically for integration of the graph. And I had this funny background that appeared for a second. This was my background presenting ETHDenver bounties. So we have this amount of prizes for ETHDenver allocated for ETHDenver. I think they will be published tomorrow, and they're split between online and offline Denver hackathons. So we will be in Denver next week, and whoever will be there, happy to meet in person. Whoever not, happy to see you participating in online bounties as well. So I guess that's most important things on my side.
Great, thank you, Evgeny. If anyone has questions, please go ahead. Just to say that those bounties will be divided 50-50. So 7,500 are for online bounties, and tomorrow we should be presenting it during the evening time Europe and morning time US. And we also will publish it in the Discord, so everybody knows. Cool. So let's move on to the next tech updates. Dmitry, do you want to share?
Hello. Yes, I do. And I want to share a part of my screen to assist me. So can you see this blue slide?
Yes.
Cool. So over the last couple of months, we were mostly working in silence, but that's not because there's nothing to do on our side. That's because we have huge updates. And I'm not going to dive into very details. I'll be very short. First, just a reminder that projects on Fluence are heterogeneous. So usually a Fluence application is coded with many languages, like the ordinary application has some JavaScript front end with fluence.js. Then it uses some Aqua language to connect peers, to interact with services, and so on. And in an ideal world, services are coded in Rust, compiled to WASM, and then run with the help of Marine. So we can think about protocols which you deploy in Fluence, these peer-to-peer protocols, as homogeneous, as they are just expressed with Aqua, but actually applications are polyglot. And for every part of the application, Fluence has some technology which is backed by another technology and maybe by another. So that forms a Fluence stack, which is a harmonized or Aquamarined, so that everything works together and helps the developer. So usually developers interact with fluence.js, but actually fluence.js is affected by the compiler, by Aqua. It has integrations between Aqua and fluence.js. Aqua compiles in the format that is supported by fluence.js. So they are kind of coupled. While Aqua itself is affected by aquavm, and fluence-js is affected by aquavm, the virtual machine that handles Aqua. And in the near future, all this setup will be affected by Marine Web when we will run WebAssembly modules in the web browser and in the JavaScript environment with help of Marine and WebAssembly interface types. So any change in any place on the right changes everything on the left. Maybe not always, but often. And for sure, fluence.js is based on libp2p, on the JavaScript implementation of libp2p. So libp2p is on the very bottom of the Fluence stack. It connects everything over the wire. Then we have a Rust implementation of the Fluence peer that we call Rust node. Rust node has many virtual machines with Aqua. So if Aqua virtual machine is changed, it means that the node probably should be recompiled or republished or updated. And aquavm runs with help of Marine, and services on the Fluence node are also running inside Marine. So that's one line. For sure, Rust node is based on libp2p, on Rust libp2p, fluence.js based on JavaScript libp2p, Rust node based on Rust libp2p. Different projects serving the same purpose, and they must connect to each other. When you interact with the node from fluence.js, actually you're using fluence.js libp2p and then Rust libp2p, and then you go to the node. And also with the node, we have a set of default WebAssembly services, which are the part of the Fluence protocol. So if a built-in service is updated, usually it affects the node, maybe as distribution, or maybe as as change in the protocol. So in any case, if the built-in service is changed, it means that the node behaves differently. And to assist in development and deployment and all that stuff, we have some tooling, like to deploy, to update, to query, to stop your service, and so on. So that's the main parts. And now what changed over the last month or like month and a half? Almost everything, because first of all, we changed libp2p. And as libp2p is on the very bottom, and this change was not backwards compatible in the libp2p level, this meant that we were forced to change the versions of everything. And all these version changes are also not backwards compatible. Maybe the code is, but all the Fluence stack is not, just to support the new libp2p. So with the new libp2p, we updated the node, the Rust node. And by the way, now we have metrics that Alexei presented on the last community call. They are vastly improved, and they will help a lot in the future with stabilizing the network. But that's one thread. Another thread in the node updates is that now we have a trust graph service as a built-in on all the Fluence peers. So trust graph is one of the fundamental promises of Fluence that we have in the original white paper in the RFC written 2 years ago, and it serves two purposes. First is it helps with managing and prioritizing the load on the node, on the Fluence peer. So it helps you to prioritize something that you can call the good load and protect from something that you can call the bad load or like spam. So that's the first problem. And this resource management part is not yet implemented, but the trust graph is here, and you can get the number of priority that we call trust weight from any public key on the network. And you can use it if you want, you can use it. The second purpose for trust graph is to manage permissions. This part is also implemented, but not yet supported over the stack. So you can use it, but it's a bit harder to do. I hope that we will have a dedicated presentation for trust graph maybe next time. I'm not sure, but it will happen. To help, to unlock more complex scenarios of trust graph usage, the sign service was implemented on the fluence.js side. So sign service is an abstraction over a key pair in fluence.js that lets you sign different payloads from Aqua. So you can ask the JavaScript peer to sign your payload, but it will not work for everything. It's protected. It's protected with the tetraplets, so it plays well with all the setup of the Fluence stack. We also have it, and you also can use it, but I'm not sure if it's documented. Probably it's not. So if you have any questions about all of this, ask in Telegram or Discord. We will help. Otherwise, we'll document it and present it later. Then, as libp2p was changed on the Node side, we were forced to update libp2p on the JavaScript side. This means that we have a new version of fluence.js. And this means that we have the new version of Aqua. So Aquarined that we had before, and all these interactions of Aqua between Aqua and the network cannot work with the previous fluence.js version. So it needs to be updated. So we have the new versions. It's 0.6, the new not backwards compatible version of Aqua. Then we have some changes in Aqua virtual machine. It's mostly about lambda expressions in array access and many bug fixes around lambda expressions in array access. Why is it needed? Why it's important? Mainly because there is a very frequently used pattern to wait for a portion of peers to respond in a four-part expression. And previously, only literals were supported. So you had to have a number like 5. While now you can have an expression instead of the number, and it simplifies the things. This thing is documented in Aqua book, and we had an announcement in the developers updates channel in Telegram. But fundamentally, this change was caused by aquavm change. And as aquavm updated, then we shipped it with the new Node version, with the new fluence.js version. So it's updated everywhere, and it affected Aqua because Aqua needs to follow all the changes on aquavm because only what is supported in aquavm can be expressed in Aqua and nothing more. Also, Aqua was deeply refactored. It was a huge refactoring without new capabilities. So there are no new syntax, no new anything else, but some thousands of lines of code changed in Aqua. Why? And what changed? There were two purposes. The first one is to provide the place in the code base to support syntax sugar. And the second goal was to improve testability of the compiler. So now we have much better test coverage for the language, and this is quite important because debugging of Aqua language is super hard, and it's better to have it as stable as possible. So now we can convert the bugs that we face to tests. Previously, many of the bugs were caught only with integration tests on a very high level, and it was very hard to debug and maintain. And speaking about sugar, well, I will elaborate this once we have some more sugar, because currently we don't have any, except lambda expressions in square brackets for accessing stream elements or array elements. But for example, one of the things, one of the language features that I want to add soon is ability to put the function call in any place where currently only the value is allowed. So currently you need to have a temporary variable to hold the value, to pass it to some other function, and now we have the place where we can just remove this unnecessary variable from the code. Yeah, and finally, fldist is dead. So we had a tool that was implemented more than a year ago, probably, and it was implemented when we had no Aqua at all. It was implemented with the low-level language with air, and we haven't had fluence-js as well. It was implemented with some very old version of all of this, and we realized that it's impossible to update it to the new fluence.js, so it cannot support the new libp2p, so it doesn't work. No functions in fldist works, and actually we even forgot about it. We don't like fldist, and we were waiting so long for it to die that we, before the hackathon, we updated everything, we checked everything, and we forgot to check fldist. And that was what we fixed, that Evgeny mentioned during the hackathon, that there should be some means to deploy WebAssembly modules to the network. It took a few hours, and now we have aquadist collection of commands in Aqua CLI. So you have aquadist deploy, probably you have aquadist remove, and some other stuff that calls Aqua under the hood, and it's a single bundle. So it's not a distinct tool anymore. It's part of the Aqua compiler, which is nice, but it has some new bugs, and it doesn't have all the features that we had in fldist. So it changed very rapidly, but we already updated the documentation, and all the main parts of aquadist works. So basically that's it. without going into the details, that's what changed. And a few words about what's going to change, because we have some prepared, big prepared things. First of all, we are very close to deliver Marine Web milestone 1. So the goal is to have the same WebAssembly modules running in the browser and in fluence-js and in the Rust node, to have the same code base and the same behavior for all the built-in services. And it will help with stability, testability, and eventually it will let us to make a full-featured JavaScript node. Currently, fluence.js can only work with the connectivity help of the Rust node, but in the future with the Marine Web, it will work on its own as well. So we'll have 2 implementations. Then we are very close to have Registry. Registry, previously aquadist, is the way to register services and to route to services on the network without knowing where exactly the service is located. So the main difference between aquadist and Registry is that aquadist wasn't secure. It wasn't protected with signatures, while Registry is secure. It's protected with signatures, and that's what was actually expressed in the RFC. And also Registry is integrated with Trust Graph. So they form a synergy between them, where Trust Graph is the grant part of a take grant model, and Registry is the take part of the take grant model. We will have a dedicated event for Registry once it's finalized, and now the code is ready, and probably it's open sourced, but we are in the middle of integration and testing. Hopefully soon it will be released. Then we are working hard with aquadist. It has many changes because we don't have fldist anymore, and now we can do things right. We can do everything like we want it to be, and this means that we will have many new utilities for CLI, for project management and application management, influence with help of Aqua. And we have some language changes in Aqua in the pipeline that will mainly focus on simplification of the development process and making syntax more lightweight, removing redundant, like replicated parts of code and such things. So that's all what I have. If you have any questions, I hope that Fluence team will help me to answer them.
I just had a small question.
Mm-hmm.
Hi there, can you hear me? I had a small question.
Yes, I can hear you.
Okay, for the registry, you said there was a certain type of model you were implementing, and I didn't quite catch that. I was wondering if it relates to like the network topology or.
Yeah, the problem is if you have a like how to figure out the way, the path to the code that you want to run. For example, I am a user and I have a browser, but I can be connected to the network with different relays and I can regenerate my private keys inside the browser for security. So how can I advertise my web browser so that you can deliver the message to me? With a registry, you can do that. So you can register the, like, you can call it topic or topic in terms of pub sub, or you can call it the root ID. And you can register many pathways and many peer IDs and service IDs to this root ID to be resolved on runtime, so that you can use this part of topology, of the network topology, when you call the code. Something like that.
Okay, I think I understand. Thank you.
Any other questions? And yeah.
I put a live to get working again. So
Sorry,
that was good.
I cannot hear you. Can you repeat, please?
Okay.
You are something with your connection. Something with your connection. We cannot hear you.
Anyways, the loud voice,
No.
No.
No. So sad by him, but we cannot.
You can type in. You can type in chat if it's.
Anyway, is it better since I turned off the? No.
It seems better a little bit.
A little bit.
All right.
No.
No. Morgan, one more word about registry. aquadist is published and used. We have different demos of aquadist, and if you take a look on it, then you will get the main idea for the registry, because registry is aquadist with signatures and security.
Okay, and you said that the registry is built in runtime, so it just lives on the network for online peers. It's not stored in a database or anything like that?
Something like that. It's deployed to all the Fluence peers. It's a part of the Fluence protocol, and it's replicated following the Kademlia DHT algorithm. So you have some redundancy, like 8 copies of every record and so on, and it's stored in the local database. So probably it should outlive the node restart. Alex, will it? Yes? No?
So, sorry, in the node restart, it doesn't get stored, you're saying, or does it get stored?
Yes, it is stored in the node.
Okay. What happens if like a bunch of nodes go down? It just gets replicated if they pop back up? And is there like a threshold or something like that that you look at that's like stating the true fact of the registry?
Every key and every value is replicated by a factor of 20 currently. So it's a lot. and if part of the network goes down, eventually, if it goes back, or if any other kind of network restructure happens, it will be replicated in the Kademla neighborhood of the hash of the ID, of the root ID, and eventually you will be able to find it.
Okay. Cool.
So there is a chance that the data will be lost, but all nodes who are in a replica set has to lose it.
Yeah, the chance is not super high, but if this data is super critical for you, probably you want to have some kind of backup. If it's really super critical, then it should be on chain.
Right. Okay, thank you. Have you ever thought of deploying a registry of like the registry of peer nodes on chain, like periodically, in like a network that might be cheaper?
Well, there is a problem of having this data available on runtime, and to have it available on runtime, ideally you want to replicate it in some known place of the network, and have it hot, have it available as fast as you can. So currently, this is what is solved. And if you want, you can back it up, or maybe eventually Fluence Network or Fluence Protocol will back it up by one or many chains. But that's the next task. And currently, having this replication factor of 20 is enough. It doesn't work.
No, we cannot hear you. And speaking about the registry data, actually, I guess the most organic solution should be that when we have the economic model, the ability to pay to nodes for hosting your services, there should be also commitment from nodes to keep the registry data that related to your application. So basically, the availability guarantees will come from their commitment. And when we talk about putting something on chain, it may be the optional kind of it may be the option, but it's the most expensive option, right? So it's kind of should be for the application developer to decide whether or not it worth paying for gas, because like every time there is an update, you need to send a new transaction,
right,
to on-chain and pay for gas. And if you use not really popular chain, then you have problems that, like, it's always the balance between the cost and availability, right?
Yeah.
So Ethereum probably will give you availability like permanent. It will be permanent. It will be forever there, but it costs a lot. If you build on someone of new chains, you don't know what happens with this data next year. It kind of depends. If you need this data to be 100% available, but only for the next, let's say, week, and then you will republish, and then you will republish, then the cost of submitting data to this chain should be comparable to this value that this chain provides. Like, I mean, like paying Ethereum gas fees for if you want to every week to republish, probably too much. So it's kind of like, it's still needs to be we need to restart this part, I think.
Yeah, maybe a side chain might be interesting, whether it's like Polygon or Gnosis chain, just because of the cheaper.
Yeah, for sure. I mean, like the problem is Polygon is that they have their own issues with growing state, and you know, who knows where Polygon will be in a few years, right? So, but in general, the ability to give the application developer the choice, the right to anchor or to deploy registry data to some of the chains, that would be nice. Yeah, I agree with you.
Well, but speaking about the guarantees and so on, there are different entities in the registry. There is the root ID, and it might make sense to have it on chain. And there are like subscribers or pathways to the code that should reflect the runtime behavior of the network. So if you can find right now, if you can find this node with this path, it should appear on the registry. But if it's not the case because of the loss of connectivity, if the node is dead or something else happened, it should disappear from the registry. Otherwise, you will have a lower level of services of the network. So what we have right now, before we have all the integrations with the chains, we have periodic updates. So if you have a service, and that's right, that's what implemented. If you use the key, if anyone on the network uses the key, the path ID, then it will not be garbage collected by the nodes. If you want it to be persisted, just use it. If you want it to be persisted, even if you are offline, for example, if you want to have your database or queue or something like that available on the network, then you can ask one or more Fluence peers to refresh this path. So we are trying to make it cheap for the peers and to avoid unnecessary job of keeping this state online, while still providing the ways for live applications to maintain and refresh it and to be sure that it's available. So I'm not sure that all of this state should go on chain, because chain is is persistent, while registry reflects runtime. But we are trying to make it as close to reality of the network topology as we can. It sounds like we have to draw some pictures and have a dedicated presentation about registry, because it grabs attention. We will prepare it hopefully to the next community call, or maybe the one after that, but hopefully the next.
Thank you. And I don't know who that was. Yeah, I was wondering if there's an ETHDenver meetup as well occurring within, I think that there was one that I saw online.
There is a decentralized network summit if you are there in person. So we're hosting that on February 15th. And then there is a workshop that we want to host offline, but we are right now defining the dates. We have like it's either also 15th of February or 16th of February. But when are you joining Denver? Which dates?
Yeah, probably the 14th or 15th.
Okay, right. Yeah, we'll announce.
Cool. Thank you.
Yeah, just Decentralized Network Summit is on calendar actually of ETHDenver already.
Okay.
So feel free to join, and on the workshop, yeah, Anna should update on the dates.
All right, thank you.
And we will host some other stuff like some breakfast, right? And I don't remember which days.
Yeah, that will be Web3 breakfast. And by the way, this the workshop will be also online. We will do either this Friday or Saturday, and we will have recording then on YouTube. And then the Decentralized Network Summit, those who cannot make it to Denver, it will be hybrid, so it will be all live streamed. So just book the online live stream ticket. We still have some.
But Morgan, feel free to come by to any of our events and say hi. Happy to meet in person.
Yeah, that'd be cool. Yeah, looking forward to it. I'll try my best. Thanks.
Okay. Right. Any other questions, topics, concerns, ideas? I know Yura has something to say, but maybe you try Telegram or Discord.
I mean, technically we can move to Discord even now if you're, but I think maybe it's connection difficulties, not the Zoom or any.
Yeah, it's on his
difficulties,
side.
right?
Yeah.
Well, hopefully next time then. Next time is going to be in 2 weeks. That's bi-weekly call. So just add it in calendar, and I'll also remind next time. Let's try again.
All right. Thanks, everyone.
Awesome, thank you.
Thank you so much, everyone.
See you next time, or in Denver, or in anywhere.
In anywhere, yeah.